Welcome to the module on earthquake. By the end of this module, you will be able to define an earthquake, explain reasons for an earthquake, identify the effects of an earthquake, identify the seismic zones in India, identify the safety procedures to be followed in an earthquake situation, and explain the role of volunteers. Hello. In this module, we will discuss earthquakes and the safety and mitigation practices one should follow when earthquakes hit or cause disaster. Now let's know about what is an earthquake. An earthquake refers to the shaking of the Earth's surface caused by a sudden release of energy within the Earth's crust. Usually, earthquakes last less than a minute. Earthquakes can be felt over large areas. The impact of the earthquakes depends on their duration, scale, and depth. Before knowing the plate tectonic, let's understand the structure of the Earth. The Earth is made up of three distinct layers. Click on the Earth's surface to view its layers. Scientists have determined that the Earth consists of three primary levels or shells by evaluating the seismograms from several earthquakes. They are crust, mantle, and core. Let's learn about each of them. The Earth's outermost surface is called the crust. The crust is relatively light and brittle. Most earthquakes occur within the crust. The region just below the crust and extends down to the Earth's core is called the mantle. The mantle is a dense, hot layer of semi-solid rock approximately 2,900 km thick. Beneath the mantle is the Earth's core. The Earth's core consists of a fluid outer core and a solid inner core. Below the lithosphere is a relatively narrow, mobile zone in the mantle called the asthenosphere. The lithosphere is composed of both the crust and the portion of the upper mantle that behaves as a brittle, rigid solid. The lithosphere is the outermost mechanical layer, which behaves as a brittle, rigid solid. The lithosphere is about 100 kilometers thick. Now let's know about what are plate tectonics. As per plate tectonic theory, the Earth's outermost surface is broken into rigid plates which are 60 to 200 kilometers thick and float on top of a more fluid zone, much in the way that icebergs float on top of the ocean. There are 7 major plates and several minor move a few inches a year, riding on semi-molten layers of rock underneath the crust. The plate tectonic theory is supported by a wide range of evidence that considers the Earth's crust and upper mantle to be composed of several large, thin, relatively rigid plates that move relative to one another. The plates are all moving in different directions and at different speeds. Sometimes the plates crash together, pull apart, or sideswipe each other. When this happens, it commonly results in earthquakes. Now, let us learn about the types of plate boundaries. There are 4 types of plate boundaries. Let us know about each of them. Divergent boundaries occur where new crust is generated as the plates pull away from each other. Convergent boundaries appear where the crust is destroyed as one plate dives under another. Transform boundaries happen where crust is neither produced nor destroyed as the plates slide horizontally past each other. Plate boundary zones are broad belts in which boundaries are not well defined and the effects of plate interaction are unclear. Now, let us learn about causes of an earthquake. Therefore, as plates contract or expand, or slide past each other, enormous forces form at their edges, causing the rocks to move violently. This produces an earthquake. As the plates move, they put force on themselves and each other. When the force is large enough, the crust is forced to break. In the event of a break, the stress is released as energy, which moves through the earth in the form of waves, which is called an earthquake. Now, let us learn about the faults. A fault is a region of stress in the earth where shattered rocks slide past one another and create a break on the surface. There are four major types of faults. They are dip-slip normal, dip-slip reverse, strike-slip and oblique slip. Now let's know about how do earthquakes happen. The plates rapidly slip past each other, generating seismic waves and causing the ground to shake.
Earth is also made up of several layers: the crust, the mantle, and the core. Can you see how thin the crust is compared to the rest of Earth's layers? Under the crust lies a semi-liquid mantle layer of molten magma, which can be divided into the upper mantle and the lower mantle. Together, the upper mantle and the crust are collectively known as the lithosphere. Below the mantle lies the core, which can also be divided into the outer core and inner core. The outer core is made of iron and nickel. But because temperatures are so high here, you find these metals in their molten, liquid form. At the center of the Earth, beneath the outer core, lies the inner core. This layer is a solid ball made of iron as well. This is the hottest part of the Earth, with temperatures as high as the surface of the sun. The inner core stays solid because Earth's gravity is so strong the metals cannot melt, despite how hot it is. If you took a look at a world map, it would be easy to think that the Earth has always looked like this and always will. However, this is just how the Earth's surface looks currently, because it is changing all the time. Most of these changes happen in the lithosphere. Earth's lithosphere is divided into many tectonic plates that are different in shapes and sizes, but fit tightly together like a jigsaw puzzle. There are 7 large key plates and several smaller plates, and our lands and oceans lie on top of them. Did you know that all of the continents that we know today once formed a single supercontinent? This supercontinent existed 335 million years ago, and we call it Pangaea. Over millions of years, the tectonic plates which hold the continents moved around, smashing into each other and then pulling apart. This process is called plate tectonics, but is sometimes also known as continental drift. If you look closely, you can see where some of the edges of the continents line up, like the edges of Africa and South America. Fossils of animals that couldn't swim or fly have been found on different continents, providing further evidence that all the continents were previously connected. So, how did the plates manage to move the continents to where they are today?
An earthquake is caused by a sudden slip on a fault. Now, let's introduce the key terms related to earthquakes. Click each term to know more about it. Epicenter is a point on the Earth's surface directly above the source of the earthquake. Focus or hypocenter is the point on the fault from where the slip starts. Seismic waves are created by the quake that travel in waves from the epicenter, where they are the strongest. Let us learn about the primary and secondary waves. Usually, there are two types of seismic waves, primary waves and secondary waves. Let's learn about them. P waves or primary waves are the first waves to arrive at a seismograph. P waves are the fastest seismic waves and can move through solid, liquid, or gas. They travel at the speed of 5 to 8 kilometers per second along the Earth's surface. They leave behind a trail of compressions and rarefactions on the medium they move through. Certain animals, such as dogs, can feel the P waves much before an earthquake hits the crust. Humans can only feel the ramifications it has on the crust. S waves or secondary waves are the second waves to arrive during an earthquake. They are much slower than P waves and can travel only through solids. They can travel at the speed of 3 to 4.8 kilometers per second. It is after studying the trajectory of S waves through the layers of Earth, scientists were able to conclude that the Earth's outer core is liquid. It is not currently possible to predict exactly when and where an earthquake will occur or how large it will be. No technology has been found which can predict earthquakes, but the difference of speed between primary and secondary waves can give a few seconds of warning before the secondary and more destructive wave hit. As soon as primary wave is detected by the instruments which are there to detect such waves, they can give a warning that earthquake is already occurred, and secondary wave can hit a few seconds later based on the distance from the epicenter. Now let's know about the fault lines existing on the Earth. The World Fault Line Map shows the major fault lines across the globe. The Earth is constantly moving, because of which there is a continuous movement of the rocks. This movement of the rocks creates fractures or discontinuity, which is better known as a fault. Now, let's know that earthquake can happen anywhere. There are also earthquakes which are not connected to fault line but can happen anywhere on the Earth without it being more or less vulnerable. An earthquake occurred in Latur city of Maharashtra in the year 1993, even though that Latur city was not in seismic zone 4 or 5. Measuring earthquakes is important for various reasons. One of the main reasons is to provide details of the scale of severity of an earthquake. There are different ways to measure earthquakes. Let us first know about the seismograph. Seismograph is an instrument used for recording the intensity and duration of an earthquake. Seismograph measures the severity of the earthquake on a Richter scale. The measurement of an earthquake's intensity is Richter magnitude scale. Each 1-point increase on the scale indicates 10 times the amount of shaking and 33 times the amount of energy. The energy released by a large earthquake may be equal to 10,000 times the energy of the first atomic bomb. Here is the chart displaying earthquake effects according to Richter magnitude range. Here is the list of major earthquakes in India with a magnitude greater than 6. According to the statistics, 3,383 earthquakes were recorded in the Indian subcontinent between the years 1800 and 2023. In the image, the red dots represent an incidence of an earthquake in that period. The identified incidences of earthquakes are 5 magnitude or higher on the Richter scale. Now, let us know about the seismic zones in India. The area of the world and of India is divided into seismic zones based on the vulnerability to earthquakes, where Zone 2 representing minimum vulnerability and 5 representing maximum vulnerability. However, depending on the intensity of the earthquake, there are some distinct zones, such as zones 5, 4, 3, and 2. Click on each zone to know more about them. Zone 5 refers to zones which are prone to extremely risky earthquakes of magnitude 8 or higher. Quakes in this zone can cause total panic and considerable damage to life and property. Northeast states, Jammu and Kashmir, Himachal Pradesh, Gujarat, Bihar, Uttaranchal, Andaman and Nicobar Islands come under this zone. In Zone 5, Bihar earthquake, 1934, with a magnitude of 8.0, was one of the major incidents. Great damage occurs in buildings with partial or total collapse. During quakes in this zone, railway tracks bend, roadways get damaged, ground cracks and underground pipes break. Landslides, rock falls and mud flows occur. Large waves are produced in seawater. Zone 4 refers to zones which are prone to extremely high-risk quakes, up to 7.9 magnitude. This zone is susceptible to strong earthquakes, which create panic all over, moving even heavy furniture. Jammu and Kashmir, Himachal Pradesh, Uttaranchal, Bihar, Delhi, Bengal, Haryana, Punjab, Sikkim, Gujarat, Maharashtra and Lakshadweep come under this zone. In Zone 4, Gujarat earthquake, 2001, with a magnitude of 7.7, was one of the major incidents. Such earthquakes could cause moderate damage in well-designed or built structures or buildings, while poorly built structures suffer great damages. Other effects could be landslides on steep slopes and cracks in the ground. Zone 3 refers to zones which are prone to moderate risk quakes of magnitude up to 6.9. In Zone 3, earthquakes of higher intensity may be felt. Earthquakes cause panic and make it difficult for people to stand. Even people in moving vehicles may feel such quakes. Punjab, Haryana, Uttaranchal, Bihar, Bengal, Gujarat, Rajasthan, Madhya Pradesh, Odisha, Andhra Pradesh, Goa, Kerala, Tamil Nadu and Maharashtra come under this zone. In Zone 3, Latur earthquake, 1993, with a magnitude of 6.3, was a major incident. Structures or buildings of good design and construction suffer minor damage, while poorly designed or constructed buildings suffer considerable damages. Zone 2 are zones which experience seismic disturbances up to magnitude 4.9. This zone is susceptible to earthquakes that can be felt by all and may frighten people enough to run outdoors. Dishes and glassware break, books fall down, and heavy furniture gets moved. The remaining parts of Rajasthan, Uttar Pradesh, Gujarat, Haryana, Madhya Pradesh, Maharashtra, Odisha, Andhra Pradesh, Telangana, Karnataka and Tamil Nadu come under this zone. In Zone 2 Rajasthan earthquake, 2006, with a magnitude of 4.0, was a major incident. A few instances of falling plaster and some damage to buildings is also observed. Most of you have probably heard of tsunamis. Tsunamis are caused by an underwater earthquake or a volcanic explosion. People living in coastal areas have to be aware that forming an earthquake may also hit those areas which are close to the ocean. Let's now watch a video on tsunami. Click the play button to watch the video.
Yeah. This is hotel room. Room number 110. Good, sir.
புரட்டி இருக்கும்
இல்லை புரட்டி தான் தூங்குறது
எப்படி எப்படி இது மேல
There are several steps you can follow to help yourself before an earthquake. Let's see those steps one by one. Before an earthquake, you should prepare a disaster kit for your home and car. The disaster kit should have a first aid kit, dry food, bottled water, power bank, flashlight, appropriate clothing, and mobile phone. Now, let's discuss some safety procedures during earthquake. Here is the first situation for you. Suppose you are at home and suddenly you feel a strong vibration. What should you do at that moment? If you are indoors during an earthquake, keep calm and take cover under a heavy table or desk. Stay away from glass, windows or anything that could fall, like a bookcase. Move only a few steps to a nearby safe place. During an earthquake, you should choose a safe place such as under a sturdy piece of furniture like a table or desk, where nothing can fall on you. Practice drop, cover and hold on, drop under something sturdy, hold on and protect your eyes by pressing your face against your arm. Now, consider the second situation. An earthquake can cause the rupture of a gas pipe, which may create a dangerous gas leak, which in turn can lead to fires and even explosions. Suppose you are at home, and if you smell gas or hear a hissing or blowing sound, what should you do at that moment? Open a window and get out of the building right away. Make sure you wear shoes as there may be broken glass on the ground and inside your home. Let's discuss the next situation. Suppose you are in a crowded public place and suddenly you feel the ground shaking violently. What should you do at that moment? You should not rush to the doors. Instead, take cover under something heavy and stay away from things that could fall on you. Most importantly, do not get into an elevator during an earthquake. Now, consider the fourth situation when you are outdoors. Suppose you are outside and standing near a building. Suddenly, you feel an intense ground shaking. What should you do at that moment? First, you should move away from buildings, street lights and utility wires and walk towards an open place. The fifth situation is here for you. Suppose you are in a moving vehicle and suddenly you feel an earthquake. What should you do at that moment? You should immediately stop driving and stay in the vehicle. You should avoid driving near bridges and tunnels. Lastly, you should avoid stopping your vehicle by power lines, signposts, trees or light posts. Let's look at the sixth situation. Suppose you are in a high-rise building during earthquake. What should you do at that moment? Move away from windows and outside walls, evacuate the building, do not use the elevators. The electricity may go out. Use emergency exit. If you are trapped, stay calm. Try to get someone's attention by tapping on hard or metal parts of the structure. Now let's see what safety procedures we should follow after an earthquake. Let us now explore the next steps after an earthquake. You should keep calm and switch on the radio and obey any instructions you hear on it. Keep away from beaches and low banks of rivers as huge waves may sweep in. Prepare for aftershocks. Turn off the water, gas, and electricity. Not light matches or turn on switches. You should immediately clean up any inflammable products that may have spilled. If you know that people have been buried, tell the rescue teams. Do not drink water from open containers. If your home is badly damaged, you will have to leave it. Moreover, you should neither enter nor go near the damaged building. If at all possible, gather food, medicine, and water containers. During and after emergencies and disasters, such as earthquakes, spontaneous volunteers can be active in response and relief operations. Let's now explore the role of volunteers. The volunteers perform various tasks, such as evacuation of victims, first aid, response to fires, relief camp management, distribution of relief material, cleaning debris, and caring for animals. Volunteers may be the focal point of community for any agency. Volunteers may act as messengers of government's advisory and disseminate warnings. Volunteers can help government agencies in restoration of utilities. Volunteers can be utilized by the state in all type of general services. With this, we have come to the end of this module. Let us summarize the key points discussed in this module. Earthquakes are the shaking, rolling or sudden shock of the Earth's surface. By analyzing the seismograms from various earthquakes, scientists have shown that the Earth is divided into three main levels, namely the crust, mantle, and core. Huge rocks grow along the margins of the Earth's plates as they compress or expand. The rocks then violently shift, causing an earthquake. There are four main types of fault: dip-slip normal, dip-slip reverse, strike-slip, oblique-slip. Large ocean waves called tsunamis are typically caused by volcanic eruptions or underwater earthquakes. Richter scale estimates the amount of energy released at the source of the earthquake. We should choose a safe place in every room during an earthquake and keep calm. Switch on the radio, TV, and obey any instructions we hear on it after an earthquake. Now, it is time to check your understanding of the topic. Answer the given questions. This is an evaluation exercise. All questions are equally weighted. You need to score at least 60% to pass the test. Read the questions carefully and select the appropriate options. Congratulations!